Okay, so we now have a driver's table, an endorsement table, restriction table, and an issue table. The issue table, every time I get a new license, a new record will go in. So this will just keep growing. The restrictions and endorsement will go somewhere else. Now we talked, we'll only have one record, or if we have multiple records because of multiple endorsements, but we wouldn't keep a historic track of what was going on. If we wanted to keep a historic track, so I had an endorsement, but then I had LASIK surgery and I don't need that, but they wanted to keep track of when I had endorsements, instead of a driver's license number being in here, we would do the issued ID number in here. That way we could keep track of which issued license is the one that had those endorsements on. Does that make sense? So if we have the driver's license number, it keeps track of our current endorsements. If we want to keep track of historical endorsements, instead of the driver's license number, we would do the issued number. And this really comes down to when you design a database, why you need to know what people are going, what they want to do with the data. Think about if you designed a database and we had all this built, we had the interface built, and then somebody says, oh no, we want to keep track of that. Well, that means you have to change the way you design the tables, change all your queries, change all the interfaces. It makes a huge expense. So one of the first things when you're designing a new information system is making sure the database is designed correctly, which is what you're learning to do in here. All right, so we have this driver's license information, and we have zip. If we make a zip, to put it in third normal form, we're going to make a zip table, which is going to be zip, city, and state. So we can get city and state out of here, and then these will move over. All right, so we have sex, right? That is going to go to a sex table, which is going to have an ID and then description. Description. So this might be 1 male, 2 female, 3 other, etc. Same thing with eye color. We're going to make an eye database, an eye table, and that will have like ID and color. So that will give us the list of acceptable colors. So we'll do 1 green, 2 brown. Oh, I got spelled right. I don't have to spell it right. 3 black, etc. So these become foreign keys. So this is a foreign key. This is a foreign key. Eye color is a foreign key. Height, where you can, we're having feet and inches. Now I will tell you, we can do it as feet and inches, but we can't really do math with it. But do you really want to do math with someone's height? It's not like we're going to multiply their height by something. If you want it as a single value, you could just store it as inches and then always convert it into feet and inches when you print it out. Class is going to be a foreign key. So we'll do the class table. So then we have an ID and we have class. So it's 1 is A, 2 is B. And of course we can have a description in there as well. Spell it right. So our class table is again foreign key. This is going to be a foreign key, but to a separate database, so we don't have any idea what's going on here. The signature in the photo goes to, has actual data stored in the database. Now, we have the driver's license and we have the date of birth. And so this will be a number, this will be a, again, I went through all that. And pretty much at this point, we have a database that's in third normal form. We have our drivers, information about the drivers, which is an ID number, date of birth, first name, last name, address, zip code, which goes to the city and state, sex, which goes to our table of descriptions, eye color, which goes to our table of acceptable eye colors, our height field, our class, which goes to the table.